Hi, today I came with a new topic in Module 1. In the last class, we discussed the mesh and node analysis of circuits by using dependent and independent sources. Right? Today, we discuss about the super mesh and super node analysis. Okay. So, what do you mean by a super mesh? You have been studied the mesh analysis in the earlier class, right? So what we do in the mesh analysis? First, we mark the currents in mesh. That means a closed path. It's known as mesh, and then apply KVL and write the equations for meshes and solve the. If there are two meshes, there will be two equations and two unknowns, and we solve for these two unknowns. Right. That was the procedure in mesh analysis. And in this case, what happens if there is a current source in between two sources? Guys, here in between in between the meshes, there is a current source Is. So can we do the same mesh in the previous mesh analysis here? No, it's not possible. So if a current source exists between two meshes, uh, what we have to do is we will collapse that into a single mesh. So we exclude this portion or we remove this portion. So that mesh is known as super mesh. That means we will erase this portion and we remove this current source Is, and so we get a large mesh that is known as super mesh, right? So the current source and any other elements connected in series with it is removed, and KVL is applied to find the other parameters. So the removal of current source provides another mesh equation. So if here normal case, if there is a resistance here, we have normal mesh equation, that is I1, I2. Okay, because of this current source, we can't write the normal mesh equation. So first we take a super mesh. Super mesh will be going through this path. So this will be the super mesh, that we avoid this Is. And one equation we get from the super mesh and one we get by applying the KVL in this branch. Right. Let us see in the examples in the previous slides. Can you get the idea of what is super mesh? Super mesh means in between two meshes there exists a current source, that is known as a super mesh. Okay, so because of this current source, we can't write the KVL or voltage current ratio, current equations in that complete mesh. So we will avoid that mesh and we form a super mesh and write the equation by excluding this current source in between two meshes. Okay, so this is an example. In this example, here we normal case, here there are two meshes, I1 and I2, and in this branch, that is the branch between two meshes, there exists a current source, this 6 ampere. So what we have to do, we will exclude this portion, that this rounded lines, this portion will be excluded. So we get a waveform, circuit like this. So this is known as the super mesh. Super mesh. Okay. So in the super mesh, we will take the currents I1 and I2, that is in the previous meshes. Right. The same I1 and the same I2. Right. And we write the equations for this super mesh. Super mesh means we take the large mesh. That is why it is known as super mesh, right? So when we are writing the equations, this will be like this. And before that, the properties of super mesh are: the current is not completely ignored. It provides the constrained equation necessary to solve the mesh current. When we are taking the super mesh, we will exclude the current source, but it is not completely ignored. This current, several current sources in adjacency form a bigger super mesh. So that is the properties of super mesh. An example, in the previous example, same examples. Here we can write the super mesh. We have a 6I1. So this one is the 6 ohm into I1, 6I1 plus 14I2, means here 10 and 4 ohm. So that is clubbed together, we get an 14. Both are in series, so we can equivalent resistance will be 10 plus 4, that is 14. So this will be 14 I2, 10 plus 4, 14. Okay. So here there is a 20 ohm resistor. When we are excluding this portion, the remaining elements are this 20 volt voltage source, 6 ohm resistor, 10 ohm resistor and 4 ohm resistor. Through the 6 ohm resistor, the current is I1. And through the 10 ohm resistor, current is I2, and through 4 ohm it is again I2. That is why we take the equivalent resistance as 14 ohm. Okay, so the remaining circuit, if we are considering the super mesh, the components will be one voltage source and one resistor, and again there is another equivalent resistor. This will be 6 ohm and this will be 14 ohm, and this will be plus minus 20 volt. So when we are applying the KVL in this super mesh, current through this 6 ohm, here it is I1. So this will be I1, and through the 10 ohm and 4 ohm it is I2. You take the same current that we marked in the first meshes, that is so I1 and I2. Not take in same current, because here we just exclude this, but there will be a dependence of this current. So that is why we are not taking these two currents as same, right? So this we take it as I1 and this we take it as I2. So when we are applying the KVL, we get 6I1 plus 14I2 is equal to 20. Got it? Okay. And next, here we have two currents, right? I1 and I2. Then now we have to find out this I1 and I2, but only one equation, right? So in order to find the next equation, in normal case, we will get two meshes and two equations, but here we form a super mesh, and hence we get only one equation and two unknowns. So in order to get the second equation, we have to apply some laws, either KCL, KVL, Ohm's laws, anything in between this excluded portion, right? So here we apply the KCL at this point, this node. So here the incoming current is I1 and outgoing current is I2, and the 6 ohm is also incoming. So we can write I1 plus 6 is equal to I2. Right. So KCL at this point. So or we can write I1 minus I2 is equal to minus 6. Okay, so we get two equations, 6I1 plus 14I2 equal to 20 and I1 minus I2 equal to minus 6. From this we can find this I1 and I2. Okay. To do it as an exercise or example. Similarly, the second example shows here there are three meshes. A normal case there are 1, 2, 3 and 4 meshes. Okay, and this here there are two current sources in between the branches. So here we can't make a super mesh by clubbing only two meshes. So here we are making a super mesh by combining three meshes. So there is no restriction on making the super mesh. Wherever the current source in between two nodes exists, so we can make it super mesh. So you go through the equations, right? Here 2i1 plus 4i3 plus 8i3 minus i4 is i3 minus i4 because the current through 8 ohm is i3. Here it is I3 and I4 direction is opposite. So I3 minus I4 is here and plus 6 I2. So this is the 6 ohm and the I2 is equal to 0. So this direction, first equation we write it as in this direction. Apply the KVL equation, and second one we mark the we take the point this one, sorry, this point P. Here I1, I2 and 5 ohm. So I1 is outgoing current and 5 ohm 5 ampere are also the outgoing current, and I2 is the incoming current. So we can write I1 plus 5 is equal to I2. So that will be I1 minus I2 will be equal to 5 minus 5. And at the at this point again we apply the KCL. Because here we have a super mesh as 1 and a normal mesh as 1, but there are totally 4 unknowns, so we need 4 equations, right? So in order to get this remaining equation, we have to use KVL or KCL at any points. So the first we apply the KCL at point P, and second you have to apply the KCL at this point, that is the meeting point of 4 ohm, 8 ohm and 2 ohm. Here I3 is the incoming currents and I4 is the outgoing current. Okay, so we get minus I3 is equal to minus I4, and next equation we getting as by applying the KVL at the second mesh. This mesh is the normal mesh. Applying the KVL at this mesh, we get it as 8 into I3 minus I4 plus 2I4 plus 10 volt. Here there is a 10 volt battery source that is equal to 0. By solving these 4 equations, we get the currents I1, I2 and I3. So we can find the mesh currents. So next is the super node. Similar like super mesh, there are also super mesh. Similar like super mesh, there is also super nodes. So the circuit having floating voltage sources with no series resistance, that will exist super nodes. So that is the two and so voltage source cannot make two independent nodes. So that is in between two nodes there exists a voltage source. Previous case was in between two nodes there exists a current source, right? Here if there exists a voltage source, what we have to do? So that is known as a super node. The supernode is usually indicated by the region enclosed by a dotted line, and the KCL is applied to both nodes at the same time. And here we consider these two nodes are at the same point, only considering, not actually it is not at the same point. And if there is a voltage source in between two nodes, by writing the KCL equation, we will assume that these two nodes are at the same point. Okay, let us see the example. So this diagram shows the what is the difference between a node and a super node. So in this case we have three nodes V1, V2 and V3, right? In V1 and V2 there is a 3 ohm resistor, V2 and V3 there is a 7 ohm resistor, and this lower point is the reference point. In the second picture, that is at the reference V picture, in V1 and V2 there is a 3 ohm resistor, V2 and V3 there is a 22 volt voltage source. So that is the difference between these two pictures. So first one is the normal we can use the node analysis, but in the second case there exists a super node, that is in between V2 and V3 there is a voltage source. So in order to analyze this we have to use the super node analysis. What are the different steps for super node analysis is given by, that is, first we redraw the circuit by considering the nodes and count the number of nodes in the circuit and design a reference node and label the nodal voltage and form a super node. Up to the fourth steps, the same thing that we do in the same thing that we done in the nodal analysis. And the fifth step is form a supernode. Supernode, how can we make the supernode? If there is a voltage source in between two nodes, we can make that two nodes as the supernode. The two nodes combined together, we make it as a supernode. And one KCL is needed to each defined supernode, which can be accomplished by simple application of KCL. And next thing is arrange these equations and system of equations and find the solution. Right. There is an example here. Simple example. Here there is a V1, first node V1 and second node is V2. In between there is a voltage source 1 volt. So normal case here, if there is a resistance in between, we will apply the node voltage at the V1 and at the node voltage V2. And here we will consider this as a super node. Okay, here the total number of nodes is 3. That is, first one is this and second is this and third one is our reference node 3. So node 0 is the reference node or ground node. Okay, node 1 and 2 form super node. So this forms the super node. Right, so clear? And apply KVL and KCL to get the node voltages. Try your own solutions. I think it's simple. You can solve by using your equations. So apply KCL means we have a at the node 1 we apply the KCL to 2 ampere in the downward direction. Here there is, and this current is I1 and this current is I2. Okay, and this current is I3. So 2 plus I1 means we flows from V1 to ground. So V1 minus 0 by 1 ohm plus I2. I2 is V2 and the ground is 0. So V2 minus 0 by 1. And the I3 is, here the voltage is V2 and here it is not at the ground potential. Here there is a 2 volt. So V2 minus 2 by 1. Right. That is getting as 0. So we get the equation V1 plus 2 V2 is equal to 0. Right. So next we have to apply the KVL to the loop having current I. Here we take this loop equation. Right. So in order to apply this loop, we consider this as our voltage source that exists between two nodes, that is 1 volt, and this point is the node voltage V1 and this point is the node voltage V2. Okay, so here we consider this loop for applying KVL. So this voltage, what is this voltage? This will is V1 and this voltage is V2. Okay, so when we are applying the KVL here we consider the direction as this. So this will be plus and minus, so it will be minus to plus. We get it as minus V1 minus 1 plus V2 is equal to 0. So V1 minus V2 equal to 1. So we get two equations, V1 plus 2V2 equal to 0 and V1 minus V2 equal to 1. So we get two equations and two unknowns. We can solve it by easily. Substituting, either you can use the substitution method or Connors rule or anything you can use to solve this equations. Here we get it as V1 is 2 by 3 volt and V2 will be minus 1 by 3 volt. Okay, I think you are clear with the what is super mesh and what is super node, and how can we solve the circuits by super node and super mesh. Okay, thank you.